right. Hi, everyone. My name is Ágnes, Vásárhelyi, so that's the correct pronunciation that I cannot use anywhere in the world, but this time, first time in Hungary, I can present, so yay. So today I'm going to tell you about what FRP is, as for my understanding, and what we are doing when we are implementing FRP. And the reason why I'm here is that I worked with such technologies for quite a period, and I ended up researching a lot about the origins, and it turned out that it has some aspects to consider when you want to adopt FRP. So I'm going to share some experiences and try to come up with some advices. So let's start with what functional reactive programming is. It was actually born the same year I was, so it's been for quite a long time. And it was Connell Elliott's idea. And according to his definition, FRP is programming reactive systems by providing composable abstractions and behaviors for behaviors and events, right? So actually, it is rather an implementation-independent idea for composable behaviors. And this one, he applied this for computer graphics, for example. So if you see the number that it was defined in 1996, so I'm pretty sure he was not speaking about my iPhone app. Yes, that's the one you're now looking at if you look up what FRP is. And this is why people usually get confused when comparing it to RxJS or Reactive Cocoa. But people got interested about the whole idea, so they started to come up with implementations inspired by his thoughts. So after tons of discussions between Connell and the whole community who started to implement FRP stuff, they ended up fixing this confusion with defining another term for FRP, which is denotative continuous time programming. So FRP is kind of more generic, so that's why people are thinking about FRP when doing reactive or functional stuff combined together. So what about continuous time? It's usually, if you run into some kind of discussions, if you're interested in FRP, I'm pretty sure you already seen Connell's comments on frameworks, FRP frameworks. And he always says that, okay, but it's not FRP because you're not talking about continuous time. So to imagine that you have values which varies over time, and continuous time means that this value always has new value. So in every moment of time, there is a value defined for this. And discrete time means that there are gaps between values. So that's usually what we model in our applications. Like when we say that it's a stream of button clicks, it means that you push the button so you have a value, and the next moment when you push it the next time, you have a new value, but this is sampling, so it's discrete. And about the denotative part, I can't get into that. I mean, it means something like mathematical definition for the composition of the abstraction or something like that. So I think it's what we rather do is just implement reactive programming paradigms in our applications, which means that they are built up from streams of values. So this is a data stream. So I mentioned, and it's the most common example, that you have button clicks and you can represent that as a data stream. So it's not really magic, but where the functional part comes in is when you have more data streams, which is totally obvious that you're gonna build up an application from more data streams. So, functional programming is where you evaluate expressions instead of executing statements, so you eliminate all mutating global state. And it sounds good, especially if you have a lot of data streams, and you will create your whole flow by combining these data streams. So for example, if you would like to get notified about the fact that you have to, for example, update your data you are presenting at the moment, then you can create a data stream from the clicks of the refresh button, for example, and then merge it to the data stream of the occurrences of reloads on your page. So you will end up having your values about refresh. So streams can be inputs to other streams, and if you understand that, you can imagine that possibilities are endless. So that's the magic. But I assume that you already have an environment where you want to port these ideas. So, for example, if it's my iPhone, I can't really implement apps in Haskell. So actually, there are several implementations that tries to port these ideas into rather imperative or object-oriented environments. So for me, it means that I have to deal with Objective-C or Swift if I got lucky. For us in the iOS or Mac world, there are a lot of possibilities already. So these are several amazing projects for example, combining event streams, implementing reactive paradigms with the hint of functional operators, future promise, or just observation. But it's really just Cocoa, so you are not alone. But it means if you are building something, it means that you are working on a product, for example. That means you are working in a team, I hope at least, and you probably have a budget too. And sometimes even a deadline. So yeah, let me share some about my story. So I worked at Prezi recently, and we worked on the Mac application, and we built up the whole app from reactive Cocoa, which is a 4-year-old framework. It counts as a mature one in our world, and it was totally Objective-C at the time. And I started over it without knowing anything about reactive or functional. So it was a great project. It was a great experiment. We had no strict deadline because it was a new product. So when we had issues, we got to fix them. So now it's good, and yeah. So let me talk about Objective-C for a moment. It's really old. it's built around the object-oriented paradigm. So you can write really cool imperative code with it, which is awesome if you like it. But if you want to do something like FRP or just simply reactive stuff, it's really difficult. So don't get me wrong, I like the language, but yeah, it's not easy. So Reactive Cocoa was the first framework which was implemented to port the FRP ideas into our world. And it also had a lot of extensions for just, you know, to extend the language with features it missed to be able to write declarative style code, for example. So it's a huge framework. And then came Swift to the picture. So it has a lot of really cool aspects. For example, it has generics, first-class functions, and they already built a lot of functional operators in it by default. So it's a lot more easier to implement anything functional reactive related today in Swift. So I thought, after starting my blog and writing posts about functional and reactive Cocoa, that very nice, now I can do reactive Swift. But actually, Swift was a new language to me, and Reactive Cocoa had a new API, so it was learning two languages at the same time. And it's not good. So back to the topic, I came up with some ideas what to consider if you'd like to adopt these kind of technologies. And I think that you have to adjust a lot more things than just code. So, for example, your team. Your team is built up from developers, and every developer has strong opinions, they have preferences, they plan tasks, and introducing RP to a team is not just about writing different style code. I think it's, for example, if someone is really into UI programming, it's going to be a totally different method. So reactive programming is an abstraction. So you're going to do something totally different, like a new language. So tasks going to take longer, for example. Yeah, also. And everyone on the team, we're going to have to learn. So these are my personal experiences. So not sure if it applies for everyone, but learning object-oriented programming was like, hey, it took time, but awesome, I can create programs. But for this functional reactive thing, it took a lot of time. And then I thought that it's magic, and then I thought that it's black magic, and it's definitely something going on under the hood I don't like. And then I understood the whole thing, and now I think that it's a much more better way to write code. But you know, with FRP, even there's a confusion about the name. So usually, this is not something you will just learn. I mean, the paradigm. You will learn the framework. So that's why it happened to me that I had to restudy the whole thing when there was a major update on the framework I was using. So yeah, it took time. And I didn't mention that in Prezi I worked with two, I think, outstanding senior engineers, and they taught me the whole thing. So yeah, it's not easy to learn. And just an update, I skipped 3 months of doing FRP and last week, I had to restudy the whole API documentation to get on it again. So yeah, if your code already exists, it means that that's a different story than if you want to write a reactive app from scratch. So I think it's better to aim for immutability and some kind of declarative design depending on your environment. But also, if you choose MVVM over MVC, you can probably adopt RP much easier, because if you have, it's going to be an iOS example, but if you have a massive view controller with tons of global mutable state, then there's a chance that you're going to end up with an even bigger mess after adopting reactive Cocoa, for example. So my advice is that really try to think about, before implementing anything like that, that if you need functional stuff, you need observers, future promise, or nothing, and you are totally okay with MVC, because that works too. But if you like to go with reactive stuff, it's really going to need time, especially if your team never seen things like this before. Because even more abstractions you add, that's going to need even more time. But there are benefits too. So I think, or my experience is that the code is going to be a lot more maintainable if you go with FRP, and also it's a better developer experience. I don't say that anything else is bad. I just say that at least working with it worth it, because you're going to have a totally different aspect on programming. Yeah, of course there are some trade-offs with testing and debugging, but it might not a generic issue, because for example with iOS and Mac, mocking was not trivial with this reactive thing, because you have to reverse engineer all the signals in your head and try to come up with tests like that. So it's quite, it takes more time. And debugging is the most difficult part of reactive. I know that Elm has something that helps you, so it's also not generic. But for example, with reactive Cocoa, you can end up with hundreds of, 1,000 deep stack trace of signals, and you can never know what happened. And a lot of people asking me about performance. So if you do something critical, like scrolling experience on a UI, there is good to skip the reactive bindings there, because it has a cost, obviously. So if you're building an MVP for your business, I'm not sure the best idea is to start out with FRP, because MVP is aimed to be the most straightforward representation of what you're trying to sell. So it's really can be time sensitive and also disposable. So if you're not aiming for a long-term maintenance of your code, I'm not sure if it worth the time. I got some calls from people who's working with reactive Cocoa, and they were complaining about creating a huge mess in their startups MVPs when introducing reactive. And it happens because people think that oh, that's a great API, I want to use this function. And then they pull in the whole hundreds of megabytes big framework and then get confused by memory leaks. And yeah, so it's not that. It's too big for just one function. The good news is that a lot of people started to create implementation for smaller parts of this whole concept, so we are saved. So what happens if you're going to scale? For example, you received your precious money and you can extend your business, you can hire more people on your team, you can implement more features. I don't say dispose your MVP, which was not reactive, and then start it again, because that's not the solution. I think if I would be in the position to start with something like that, I would start with an application with as functional styled as possible, and then move to FRP if I'm there, if I have the team and the money for that. So I think the most important thing is that watch out for your own context. So it's really worth to research these ideas before starting out with it. So FRP is not just about observables. It's really a deeper idea, and it worth your time. So my idea is to get inspired, and this is my Twitter handle, and this is my blog where you can read my journey with reactive programming. Thank you.
All right. Thank you, Ágnes. We already have quite a few questions on Slido.
Nice.
And here we go. Just going to leave you with it.
Oh, okay. Easier to express in FRP. Not sure about patterns, but I'm not sure about this. I mean, if you do FRP, is that you have tons of signals everywhere in your app. I don't know what patterns you're talking about. If you're here in the audience, maybe can you clarify if you have an exact pattern you're looking for?
Also, if you're here and you don't feel comfortable speaking about it right now, maybe you can talk to Ágnes after the talk and approach it then.
Okay, okay.
Yeah, so we can take that one offline.
Okay, okay. Thanks. Some examples. Yeah, for example, if you're working with async operations that you want to chain, for example, like network requests, and then FRP makes it really easy. And also, if you're working with the UI, you can create bindings, for example, straight from a view to the view model, and then just update all your model based on the interactions of UI directly. Yeah. Oh, yeah. That's a good question, Yuchi. Yes, I would definitely wanted to learn some hassle before doing any FRP, and it's because if you're not aware of the concept of the whole composition, it's really hard to adapt to this way of this new thinking. So I think functional plays a role in it, which is necessary to have. Yes, so pure functions help, of course. What I mentioned about testing, it was really not generic. So I think it's more testable, yes, but it kind of depends on your environment. So with hacking FRP into Objective-C and then testing it, it was not straightforward, and for me it took more time, but eventually it's more testable, yes. No, it wasn't, but but I think it was because we had this architecture from day one, and like MVVM, and we were really taking care of the separation for all the development. Our only issue was when we overdid the reactive stuff, and we introduced this FRP thing to our business logic, and then a lot of things went async. We really didn't want to be async, so we ended up with an unsynchronized mess of crashing code. But there's a solution for that too. So for example, with Reactive Cocoa, the solution was implementing dedicated schedulers for every major actor and then just dispatch everything around. I'm not sure if it's a future-proof solution, but if you have a better idea, let me know.
All right, that's it. No more questions on Slido. Do we have any more questions in the room? No. All right, so thank you very much, Ágnes. We're going